Hello there! And welcome back to Smart Student TV, the only channel where academic and professional prowess is nurtured right from the comfort of your living room. Whether you are a student striving for excellence, a professional looking to sharpen your skills, or simply a lifelong learner, you are in the right place. In today's tutorial, we dive into a vital yet often overlooked topic: laboratory hazards. Laboratories are at the heart of scientific discovery and learning, but they also come with risks that, if ignored, can lead to accidents, injuries, or even loss of life. The objective of this chapter is to highlight the importance of understanding laboratory hazards, how to identify them, and, most importantly, how to eliminate or minimize these risks for a safe working environment. So, grab your notebooks and stay tuned as we ensure safety and success in every laboratory session. Let's get started. Let's start by understanding the term hazard and risk. First, what is a hazard? A hazard is any source of potential damage, harm, or adverse health effects on something or someone. How about risk? Risk is the chance or probability that a person, property, or environment will be harmed or experience an adverse health effect if exposed to a hazard. Laboratories are among the most contaminated workplaces globally. This is because of the nature of samples handled and also the reactions taking place in this facility. Most of them are either highly pathogenic, carcinogenic, radioactive, etc. This means that laboratory hazards can cause several harmful effects to the laboratory user, which may include 1. Injury and deaths to laboratory users. 2. Loss of working hours. 3. Damage to equipments, supplies, and records. 4. Contamination of laboratory reagents. 5. Damage to adjacent building environment. Laboratory safety is concerned with all safe practices in the laboratory. Failure to observe laboratory safety practices will result in risks and eventually accidents. A good laboratory management is that which always strive to minimize chances of risks in the laboratory environment. The main objectives of laboratory safety programs is 1. To identify the hazards and assess the risk to the staff and others. 2. Prepare and implement an effective code of practice. 3. To check whether health and safety codes are being followed. 4. To ensure that staff knows how to work safely, what to do when an accident occurs, and how to carry out emergency first aid. 5. To ensure all laboratory accidents are reported informatively and investigated properly. 6. To promote safety awareness. Laboratory hazards are grouped according to their causes. They consist of 1. Physical or mechanical hazards. 2. Chemical hazards. 3. Biological hazards. 4. Radiation hazards. 5. Electrical hazards. 6. Fire hazards. Let's begin by looking at 1. Physical or mechanical hazards. As the name suggests, mechanical hazards includes all those physical injuries, e.g. cuts, bruises, fractures, dislocations, back injuries, etc. caused by external objects/equipments or machineries. On the other hand, physical hazards consist of all those hazards caused by high or low temperature, poor lighting, poor ventilation, noise, vibrations, etc. Generally, physical or mechanical hazards can be caused by 1. Poor or careless handling of articles. 2. Poor use of hand tools. 3. Fall of the person on hard floor or on sharp objects. 4. Heavy objects falling on the person. 5. Stepping on or knocking against sharp objects. Physical hazards can be prevented by 1. Providing environment in a laboratory with optimum working temperature, lighting, ventilation, noise, vibration, etc. 2. Careful handling of hand tools. 3. Avoiding using excessive force when clamping, cutting, or bending glass tubes. 4. Being careful when transporting glasswares. Use laboratory trays and trolleys to carry glasswares. 5. Proper training and following instructions. 6. Ensuring the laboratory floors are not slippery. 7. Avoid carelessly placing obstacles on the way or leaving items lying on the floors. Next, let's discuss the cryogenic hazards. Simply defined, cryogens are fluids at extremely low temperatures such as 1. Liquid oxygen minus 182 degrees centigrades. 2. Liquid nitrogen minus 195 degrees centigrades. Cryogens are usually kept in a metallic thermos flask called dewar, which are never sealed because if they are sealed, they will develop a pressure buildup which could lead to an explosion. There are 3 groups of health hazards associated with cryogenic liquids: extreme cold, asphyxiation, and toxicity. 1. Extreme cold hazard. Cryogenic liquids and their associated cold vapors and gases can produce effects on the skin similar to a thermal burn. They also cause cold burns if they get contact with skin. Brief exposures that would not affect skin on the face or hands can damage delicate tissues such as the eyes. Prolonged exposure of the skin or contact with cold surfaces can cause frostbite. The skin appears pale bluish due to poor circulation. There is no initial pain, but there is intense pain when frozen tissue thaws. Unprotected skin can stick to metal that is cooled by cryogenic liquids. The skin can then tear when pulled away. Even non-metallic materials are dangerous to touch at low temperatures. Prolonged breathing of extremely cold air may damage the lungs. 2. Asphyxiation hazard. When cryogenic liquids form a gas, the gas is very cold and usually heavier than air. This cold, heavy gas does not disperse very well and can accumulate near the floor. Even if the gas is non-toxic, it displaces air. When there is not enough air or oxygen, asphyxiation and death can occur. Oxygen deficiency is a serious hazard in enclosed or confined spaces. Small amounts of liquid can evaporate into very large volumes of gas. For example, 1 liter of liquid nitrogen vaporizes to 695 liters of nitrogen gas when warmed to room temperature, 21 degrees Celsius. The continuous production and leakage of some cryogenic fluids, e.g. oxygen, can support growth of aerobic microorganisms or accelerate growth of infectious aerobic microorganisms. 3. Toxic hazards. Each gas can cause specific health effects. For example, liquid carbon monoxide can release large quantities of carbon monoxide gas, which can cause death due to suffocation almost immediately. Refer to the Materials Safety Datasheet for information about the toxic hazards of a particular cryogen. Liquid nitrogen can cause explosion due to blockage of tubes or pipes due to formation of ice where moisture from the air is frozen. Cryogens are transported in glass vessels. These is normally a very delicate endeavor because the glass may fall or be subjected to thermal shock which could lead to spillage. Some cryogenic fluids, e.g. oxygen, are fire risk because they support combustion, and in case of any leakage they can ignite and support fire. To safely use cryogens. 1. Avoid all body contact with cryogens by wearing protective clothing. 2. Ensure proper ventilation to discourage pressure build-up. 3. Use the right containers, which can sustain and withstand the rapid changes in temperature. 4. Never mix different cryogens together. 5. Never use oil or grease on the equipment containing liquid oxygen. 6. Keep all organic compounds away from liquid oxygen. 7. Ban smoking in the immediate area. 8. Always use goggles, face shield and cold-resistant gloves when handling cryogenic liquids. 9. Make sure that any container used to hold cryogenic liquids are suitable for use with extreme cold. Hazards of compressed gases include: 1. Inert non-toxic gases like helium, argon, and even nitrogen reduces the concentration of oxygen in the air below the safe level, especially in confined areas, leading to drowsiness, hence doing mistakes and accidents. 2. Toxic gases, e.g. chlorine, ammonia, and sulfur dioxide, etc., can lead to toxic anoxia, especially when released in large quantities. Also, even small leakage of these gases can lead to irritation. 3. Compressed gases can cause asphyxiation due to a slow leak that goes undetected. 4. An otherwise harmless gas can displace enough oxygen in a room to kill. 5. Flammable gases, e.g. methane, acetone, etc., may cause fires and explosions, especially when they are in contact with some metallic elements. 6. Decomposing gases, e.g. ethane, releases carbon and hydrogen, accompanied by release of large quantities of heat. Cylinders carrying compressed gases may explode due to exposure to heat and if dropped carelessly. Safe use of compressed gases involves: 1. Understanding gas cylinders color-coded for easy identification. The color codes are as follows. Hydrogen cylinder, red. Ethylene acetate cylinder, maroon. Normal air cylinder, gray. Oxygen cylinder, black. 2. The actual names of the gases should also be given on the cylinder together with other information should be recorded on the neck of the cylinder, e.g. their date of filling, pressure and capacity of the cylinder, etc. 3. When cylinders are received in the laboratory, they should be checked immediately for any damage and for correct identification. It is important to ensure that no cylinders and cylinder fittings are damaged. 4. Cylinders should be fixed in an upright position. 5. Never tamper with cylinder heads, valves, or pressure control gauges, or any cylinder safety device, or attempt to use a regulator that is not designed for use with the gas you are using. 6. Never use an adapter to make a regulator fit your cylinder. Use the regulator that fits. 7. Always use a cylinder cart to move compressed gas cylinders from one location to another, and always secure the cylinder to the cart with a chain or strap and buckle. 8. Do not drop cylinders. Do not allow cylinders to strike each other. Keep all compressed gas cylinders capped until ready to use, and then place the correct regulator on the valve. Recap when work is finished. 9. Always keep the cap on the cylinder while moving it and keep it in place until the cylinder is secured. Always cap empty cylinders. 10. Never use oil, grease, or other combustible substances with oxygen cylinders, valves, or regulators. 11. Never deface or remove the product identification label on a cylinder. 12. Do not use unlabeled cylinders. 13. When you empty a cylinder, leave some positive pressure in the cylinder, close the valve, replace the cap, and mark the cylinder empty. 14. Cylinder status tags are very convenient for marking cylinders as full, in use, or empty. Use a piece of label tape, write empty on it, and place it on the cylinder. 15. When using compressed gas cylinders, you should know the properties and safety precautions of the gas before using it. 2. Chemical hazards. Chemical hazards are hazards associated with transportation, storage, and handling of chemicals. Such hazards include A. Corrosive, reactive, toxic, harmful or irritating chemicals. B. Fire caused by flammable chemicals. C. Cancer due to radioactive substances and mutagen. A. Corrosive chemicals. Corrosives are materials, such as acids and bases, caustics, alkalis, which can damage body tissues because of splashing, inhalation, or ingestion. They may also corrode metals while releasing flammable hydrogen gas. They may damage some plastics. Some corrosives, such as sulfuric, nitric, and perchloric acids, are also oxidizers. Thus, they are incompatible with flammable or combustible material. They may release toxic or explosive products when reacted with other chemicals. They may liberate heat when mixed with water. Precautions for handling corrosive materials. A. Wear appropriate skin and eye protection. B. Use in the weakest concentration possible. C. Handle in a chemical fume hood. D. Use secondary containers when transporting and storing corrosives. E. Always dilute by adding acids to water. F. Dilute and mix slowly. G. Store acids separately from gases. B. Reactive chemicals. Reactive chemicals are those chemicals that may A. Be sensitive to jarring, compression, heat, or light. B. React dangerously with water or air. C. Burn, explode, or yield flammable or toxic gases when mixed with incompatible materials. D. Vigorously decompose, polymerize, or condense. E. Toxic, corrosive, oxidizing, or flammable. NB. Some chemicals may not be dangerous when purchased but may develop hazardous properties over time. When using dangerously reactive chemicals. 1. Understand the hazards associated with these chemicals and use them under conditions which keep them stable. 2. Store and handle away from incompatible chemicals. 3. Keep water-reactive chemicals away from potential contact with water. 4. Handle in a chemical fume hood. 5. Wear the appropriate skin and eye protection. 6. Work with small quantities. 7. Use up or dispose of these chemicals before they attain their expiry date. C. Nerve poisons. Nerve poisons are those that when they are absorbed into the body, they upset the nervous system, e.g. morphine, opium, etc. Nerve poisons are divided into two. A. Sedatives. They cause the nervous system to relax. B. Stimulants. Cause the nervous system to be excited. D. Irritating chemicals. Irritating chemicals can cause inflammations and irritation of skin, mucous membranes and respiratory tract following immediate or prolonged exposure. All chemicals in the laboratory should be regarded as poisonous, including distilled water. E. Carcinogens, mutagens, allergens. Carcinogens are chemicals that have ability to induce cancer. Carcinogenic effects takes long before its symptoms appear, unlike toxic chemicals. Mutagens are chemicals which produce mutation of the germ cells, leading to generally induced malformation, spontaneous abortion, or death of the offspring upon exposure. Allergens are chemicals which causes allergy or hypersensitivity reaction when they are exposed to the skin, causing dermatitis. When inhaled, they cause asthma. General safe use and storage of toxic substance. A. Highly toxic, irritating, and harmful chemicals should be stored under lock and key. B. Only authorized persons should handle toxic chemicals. C. Highly toxic chemicals should always be handled with care, and hands should be washed after handling them. Also wear protective PPEs. D. Fuming chemicals should be handled in a fume chamber. E. Never taste or mouth pipette any chemical in the laboratory or use any laboratory ware for food as utensils. F. Avoid using carcinogenic substances in the laboratory. Instead, seek alternative, safer substitute for them. G. Young children and expectant mothers should not come closer to carcinogenic substances. H. Corrosive chemicals should be stored at lower level shelves. I. Never store sodium and potassium hydroxide in a ground glass stopper. J. Always pour corrosive chemical at or below eye level, slowly and with great care to avoid splashing. K. When opening a corrosive chemical, place a cloth over the neck of the bottle. L. Exercise great care when diluting or dissolving corrosive chemicals, e.g. sodium and potassium. M. Never add water to an acid, but add acid to water slowly by the edge of the bottle. B. Oxidizing chemicals. These are substances that evolve oxygen when they come in contact with other substances and may cause them to burn strongly or become explosive in presence of heat, e.g. peroxides, dichromates, potassium permanganate, chlorates, etc. Oxidizing chemicals can increase the speed and intensity of a fire by adding to the oxygen supply, causing materials that would normally not burn to ignite and burn rapidly. Oxidizers can also 1. React with other chemicals, resulting in release of toxic gases. 2. Decompose and liberate toxic gases when heated. 3. Burn or irritate skin, eyes, breathing passages, and other tissue. Precautions when using and storing oxidizers include 1. Keep away from flammable and combustible materials. 2. Keep containers tightly closed unless otherwise indicated by the supplier. 3. Mix and dilute according to the supplier's instructions. 4. To prevent release of corrosive dusts, purchase in liquid instead of dry form. 5. Reduce reactivity of solutions by diluting with water. 6. Wear appropriate skin and eye protection. 7. Ensure that oxidizers are compatible with other oxidizers in the same storage area. C. Flammable and combustible chemicals. Flammable and combustible substances are substances which readily catches fire and burns. These chemicals have low flash point, i.e. low temperatures at which the vapor above the liquid can be ignited in air. They therefore have high risk of catching fire. Flammable chemicals can be classified as A. Extremely flammable chemicals. These are liquids with a flash point below 0 degrees centigrade and a boiling point of 35 degrees centigrade or below, e.g. acetone and diethyl ether. B. Highly flammable chemicals. They are liquids with flash points below 21 degrees centigrade or solids which readily ignite after a brief contact with a flame or which evolve highly inflammable gases when in contact with water or moist air, e.g. absolute ethanol and methanol. C. Flammable chemicals. They are liquids with flash points of between 21 and 50 degrees centigrade, e.g. glacial acetic acids, xylene or acetic hydride. Safety storage and use of flammable chemicals involves 1. keeping only small quantities of flammable chemicals on laboratory benches and shelves. 2. Store stock supplies, particularly those that are highly flammable, in a closed steel or thick plywood box at ground-level shelves, preferably in a cool and well-ventilated outside locked store. 3. Do not store oxidizing and reducing chemicals together. 4. The storeroom should have adequate, suitable, and well-maintained fire extinguisher. The lab should also be well ventilated. 5. Avoid naked fires near the store or when opening the container containing flammable chemicals. 6. Flammable chemical containers should be always tightly sealed to discourage escape of vapor. 7. Place a "No smoking" label on the door to discourage smoking around the flammable store. 8. Use tray to hold the container to prevent the liquid from spilling on the floor in case of spillage. 9. Use water bath to heat flammable chemicals. D. Poisonous chemicals. A poisonous chemical is any substance which, when taken into the body in insufficient quantities, is capable of injuring or causing death to the casualty. The term toxic relates to poisonous or deadly effects on the body by inhalation, ingestion, or absorption, or by direct contact with a chemical. A toxicant is any chemical that can injure or kill humans, animals, or plants. The term toxicant is used when talking about toxic substances that are produced by or are a byproduct of human-made activities. The word toxicity describes the degree to which a substance is poisonous or can cause injury. The toxicity depends on a variety of factors: dose, duration and route of exposure, shape and structure of the chemical itself, and individual human factors. Toxins can gain entry into the body by 1. Inhalation of gases, vapors and particulate material, e.g. mists, dusts, smoke, and fumes. 2. Absorption through skin of liquids, solids, gases, and vapors. 3. Ingestion of chemicals directly or indirectly via contaminated foods and beverages and contact between mouth and contaminated hands, nail biting, smoking. 4. Injection of chemicals through needles and other contaminated laboratory sharps. Poisons cause undesirable effects to living organisms. They can cause one or more toxic effects, which can also be immediate, acute, or long-term, chronic. Toxic effects of toxic substances may be classified as follows. A. Local toxic effects. Local toxicity effects are those that occur at the site of first contact between the biological system and the toxicant, e.g. on skin, mouth, eyes, and respiratory drugs. B. Systemic effects. These effects always occur away from the site of body contact with the poison. The poisons are absorbed and distributed away to some other sensitive sites, e.g. in the central nervous system, neurotoxin, the liver, hepatotoxin, kidney, renotoxin, and other hematopoietic tissues. C. Selective toxicity. Refers to its ability to injure one tissue, organ, or cell without harming another one, even if the two organs, cells, or tissues may be in intimate contact with each other. D. Mutagenic effects. A mutagen is a substance that causes damage to the genetic makeup or DNA of an organism. Exposure to chemical mutagens increases the likelihood of DNA damage, and these can lead to hereditary. E. Carcinogenic effects. Carcinogenic substances are those substances that have the ability to induce cancer or tumors to living organisms. Most but not all carcinogens act directly on the DNA. F. Teratogenic effects. Erodogenic effects involve the production of gross structural deformation or malformation during fetal development. These developmental abnormalities include body deformities or organ failure in newborns. These hazards normally arise during early periods of pregnancy, i.e., when the embryo begins to form. 9. Reproduction effects. These effects are caused during the time when female and the male reproductive systems processes such as ovulation and sperm production, implantation of the fertilized egg, etc. 3. Radiation hazards. Radiation is caused by disintegration of radioactive substances. Radioactive substances are mostly heavy unstable metals which break up into small particles that are more stable. Disintegration process usually will give out energy which is part of the electromagnetic spectrum, i.e. radio waves, microwaves, infrared, visible light, UV light, X-ray and gamma rays. Radiations induces changes in genetic makeup, mutation, and can cause cancer. Radiation hazards can be acute or chronic, immediate or long-term. The three common types of radiation include A. Alpha radiation. These are radiations associated with a loss of streams of helium atoms, which are normally positive, charged. Alpha particles are heavy particles with low penetrating power. Nevertheless, they are able to destroy by causing ionization of other atoms and cells that they pass through. B. Beta radiation. Beta particles are associated loss of with streams of electrons emitted from nuclei of radioactive isotope. These negatively charged electrons have moderate penetrating power and can destroy cells, tissues, and organs by ionizing them. C. Gamma radiation. These are radiation without charge. They are very light and therefore have high penetrating power through cells, tissues, and organs, which they destroy by ionizing them. Prevention of radiation hazards. 1. Radiation hazards can best be prevented by staying away from radioactive substances. 2. Alternatively, the use of radioactive materials should be carefully controlled. 3. They can also be prevented by using proper protective clothing and radiation indicators, e.g. pocket dosimeters or special film badges. These gadgets are usually placed in pockets or attached to the lab coat, and they measures the amounts of radiation one have taken. 4. The gadgets shall then be taken for analysis in special laboratories to determine the amount of radiation one has taken in from the laboratory. 5. Only well-trained laboratory personnel should be allowed to work in such radiation laboratories and should use protective clothing. They must regularly undergo routine medical examination. 6. Radioactive materials must be stored in a restricted access conditions in a block of lead that is surrounded by a thick wood or concrete block and be clearly labeled. 7. There should be radiation warning signs placed on the lab coats. 5. Electrical hazards. Electrical hazards are hazards caused due to electricity. Electricity is the flow of electrons in a closed circuit. Electricity can cause electric shock, direct burn, and secondary injury from non-lethal shock. It can also cause fires and explosions. Static electricity is a form of electricity produced when electricity is displaced on the surface of a material. It occurs because of friction when two surfaces move over each other. Static electricity can cause high voltage to be created on a material, which can be discharged as sparks at critical level. The energy of the spark is enough to initiate dust or vapor explosion. Electrical hazards can be prevented in various ways. 1. The electrical equipment must be earthed to discharge. 2. Electrical appliances must be carefully selected, correctly installed, and adequately maintained. 3. Wiring should be done by qualified persons and be inspected by accredited company on regular basis. 4. Worn-out cables should be replaced immediately. 5. Always switch off the power before removing the plugs. 6. The color coding of the wire should follow the conventional color code, i.e., live wire, red or brown; neutral wire, black or blue; earth wire, green or yellow. 7. Install a voltage stabilizer between the supply and the consumption point, and circuit breakers should be used to cut off the supply in case too much current shall pass through. These prevents the main switch from being blown off. 8. All conducting wires must be properly insulated, not left hanging and away from water points, e.g. water taps. 6. Biological hazards. Biohazards. Biological or biohazards are hazards caused by living organisms, e.g. poisonous plants, animals, or infectious microorganisms. Hazards caused by plants are known as botanical hazards, and those caused by animals are zoological hazards. Zoological hazards occur because of poor handling of laboratory animals, e.g. worms, rabies, chickenpox, etc. Botanical hazard occurs because of contact with poisonous plants, e.g. datura and Sodom apple. Microorganisms, e.g. algae, fungi, bacteria, and virus that may cause illness or death. These are called microbial hazards. Protective methods for biological hazards. 1. Wear protective clothing when handling lab animals and plants. 2. Clean or disinfect tables using appropriate disinfectants before and after experiments. 3. Incinerate used materials as soon as possible. 4. Use protective clothing only in the lab and never use it outside the laboratory. Leave them in the laboratory. 5. Never smoke or eat anything in the laboratory. 6. Do not store any material in a food refrigerator or mix with other food utensils. 7. Wash your hands thoroughly with an appropriate antiseptic after every practical. 8. Avoid body contact with laboratory animals and plants. 9. Ensure maximum care when handling and storing carcinogenic chemicals. 10. Infected animals should never be used for any practical. 11. Stock of fresh lab animals must be obtained only from a reliable source. 7. Fire hazards. Fire is simply a product of heat and light that is evolved during a chemical reaction called combustion. It relies upon the presence of oxygen from the air reacting with flammables. Fire is combination of oxygen, fuel, and ignition source and cannot take place when one of the element is missing. This can be represented in a fire triangle as shown below. The table below illustrates the various classes of fire and their respective fire extinguishers. Class fuel examples: fire extinguisher. A solid organic carbonaceous material: rubbish, wood, paper, textiles, water, carbon dioxide, foam, dry powder, etc. B. Liquids or easily melted solid organic compounds: petrol, ethanol, plastics, etc. Carbon dioxide, foam, dry powder but not water. C. Flammable gases: petroleum gases, carbon dioxide, foam, and dry powder. D. Flammable metals: sodium, magnesium, etc. Dry powder, carbon dioxide. E. Electric faults: carbon dioxide, dry powder but not water. Safety precautions for fire hazards includes: 1. Every workplace must have a fire extinguisher, wide enough exit door opening outwards or sideways but not inwards. The door should be marked in red and no obstructions should be on the way. 2. Regular inspection of fire safety should be in any workplace and records kept. 3. Regular fire drills should be held in which the staff and the public should be informed and made familiar with the emergency routine to be followed in case of fire outbreak. 4. There should be a final point of meeting from the adjoining fire risk areas where everybody who may have escaped the fire tragedy in the building should assemble and their names taken so as to easily identify those that could still be trapped inside the building. This point should be easily accessible and protected from fire risk. 5. In case of fire, the personnel inside the building should be immediately evacuated from the fire risk area. While trying to slow down the spread of fire, all doors and windows should be closed to rid off oxygen supply from the room. Then call the fire brigades and raise the alarm for everybody to run to the fire assembly point where the roll call will be taken.